Okay, hello, welcome to my channel. Now in this video, we want to find the antiderivative of 1 over 1 plus the tangent of x, and we are going to do that over the x variable. Okay, very nice. Now this is the day 29, alright, so we are almost done with our 30 integrals in 30 days. But then we'll still continue doing some math for fun, some other integral questions and some other things, alright? Okay, very nice. So look at this question, 1 plus the tangent of x at the bottom. The denominator is just 1, and we are doing that over the x variable. Well, on the day 27, we did something similar to this, but here was the cosine of x, right? And I started by multiplying top and bottom by the conjugate of the bottom. That is, I changed this place to minus, right? And that gave us a difference of 2 squares, which we were able to figure out something for it, like 1 minus cosine squared will be sine squared of x, and that was very nice. Okay, and on the day 28, that is the previous day, right? We changed this place to 2, and this place was cosine. But we didn't make use of the multiplication by the conjugate, rather we use the Weierstrass substitution, right? But here, which one are we going to make use of? Well, I'm going to choose a completely different method for this. You can try the Weierstrass substitution by converting the rational trig function, alright, into some rational algebraic expression. That is what the Weierstrass substitution will do for you, right? And see if it will work. But for now, I'm just going to do this. I'm going to start off by making an easy replacement, that is trig identity. We know that tangent is the same thing as sine over cosine, right? So I'm going to put 1 at the top divided by 1 plus. In place of tangent, I'm going to put the sine of x, okay, divided by the cosine of x. Let me clean this and write it again, right? And then we put the dx over here in its main position. Okay, that's nice. Well, let's multiply the numerator and denominator by cosine. That is to say, we're going to have this to be the integral, multiply this by the cosine of x, right? And then we also multiply the denominator here, by cos x, cosine of x. That means we're going to have the cosine of x at the top, divided by cosine of x times 1, right? Will just be the cosine of x. And then we add it with, well, we will multiply cosine by sine over cosine. We are just going to have sine there, right? And then we can put the dx over here. Okay, very nice. So this becomes, well, notice something. This denominator is cosine of x plus the sine of x, right? While the top is just cosine of x. Look at this cosine. Well, if we usually like our integral to be that the derivative of the bottom will give us the top. You know, if the derivative of the denominator gives you the numerator, then the integral will just become the natural logarithm of the denominator, right? And that is going to be very easy. And also, if the denominator and the numerator are the same, you know, we are just going to cancel, and then we have to integrate 1 over whatever variable the functions had. And then that will also be very nice, isn't it? So what I can do now is to try to make the top to be at least the derivative of the bottom, right? And to do that, that means we're going to have the derivative of cosine should be negative sine. I should have a negative sign here, since the derivative of sine is positive cosine already. So we just need a negative sign here. Okay, so this is how I'm going to do. I'm going to first of all multiply this fraction by 1. And the version of 1 I'm going to multiply it is 2 over 2. You know, 2 over 2 doesn't change it, right? Since we are just multiplying. So doing that, we're going to have 1 half of the integral of 2 times the cosine of x, right? That is 2 cos x. Okay, and then we divide that by cos x at the bottom plus the sine of x. And then we can put the dx over here. So you notice this large space I've left. I want to do something. I want to do addition by 0 at this top. Addition by 0. What do I mean? Well, this and that will still be the same, because we are going to just add 0 to the numerator, which doesn't change the numerator, right? And the version of 0 I'm going to add is this. You know, we need cosine minus sine so that we can get this. If we differentiate this, we just get the numerator, right? Okay, so if I subtract cosine here, you notice subtracting cosine from cosine 2 will give us the positive cosine, as we had earlier. And then I want to also subtract sine, because we need to subtract sine, right? So that we can get it to be the derivative of cosine at the bottom. Okay, but then I've changed the numerator, so I need to do the addition by 0, which I said I need to balance this by, if I subtracted cosine, which wasn't there before, I need to add it back. Okay, and I subtracted sine, I also need to add it back. right? And then we have the dx over here. Okay, that's nice. Let's see what we have. So this can become the integral of 1/2 of the integral. So 2 cosine x minus cos x will just be positive cosine x, right? Let's manage some space with a lot of reasons. Okay, so we just have cosine of x at the top, and then that is 2 cos x minus cos x. Then we said minus sine of x, right? Now I'm going to break these fractions apart. I'm going to split the fractions. The first 3 terms will go together, which we've just done here, and then I'm going to divide it by the denominator, which is the cosine of x plus the sine of x, and then I can put the dx here. All right. Okay, maybe let's do it one after the other. Then after that, I'm going to split the fractions later. So we see what we have. The first 3 terms. Then we have just cosine of x plus sine x, which is exactly equal to the bottom. So we just have put it there as plus the cosine of x plus the sine of x, and then we divide that by the bottom, which is cosine of x plus the sine of x, and then we can put the dx over here, isn't it? So as you can see, this term and that term, they're exactly equal to each other, so they will just give us 1, right? Okay, so this becomes the integral, or 1/2 of the integral. Well, maybe let's just do the work at once here. So you're going to notice this cosine of x minus sine of x divided by the cosine of x, right? If we let u to be the denominator, to get dx we need to differentiate it, right? The derivative of cosine is going to be negative sine, while the derivative of sine will be the positive cosine. So the derivative of the bottom in this first fraction is the numerator completely. That means we are going to have the natural logarithm of the bottom, right? That is going to be the natural logarithm of cos x plus sine x. That is very nice. And now let's get over to the second fraction real quick. So as you can see, the top and the bottom are exactly equal to each other. That means that the fraction will give us just 1. So if you integrate 1 over the x variable, we just have x, right? So this is just x, and then 1/2 is out here. So if you like, you can split it to everybody inside, or if you don't like, you can just add an arbitrary constant and call this the antiderivative of that function right there. Okay, so this method is a lot easier. You can try the Weierstrass substitution, or maybe try to convert this to the Weierstrass substitution, or you try to see if you can multiply top and bottom by the conjugate of the denominator and see what you can get from there. Okay, so this was for fun, right? No, this was the day 29. So please, thanks for watching, and share this video with your friends, and let me also see your questions or your comments in the comment section. All right, see you in the next video.